Hi everyone, my name is Tiger Zhang, and it's a pleasure for me to explain the solutions. Before we get started though, I want to mention something. Whenever you're doing a math problem or looking at a solution, you should think about how do you get to that solution instead of what is the solution. I'm going to make all the solutions kind of intuitive so that you can understand what I'm talking about. Let's get started. Problem 1. A fully charged iPhone's battery can last 4 hours without charging if you're recording a video, and 6 hours if you are playing back video that you have already recorded. What's the maximum time in hours that you can record and play back a video on the fully charged iPhone without recharging? So for clarity, let's make the amount of battery that the iPhone has as B when it's full. And also, let's denote the maximum time that you can record the video as X. So let's think of how much battery should recording the video use. So if the video's 4 hours, it will use the battery completely. So if the video's X hours, then what would happen? Well, think about it. X out of 4 of the battery will be used. So X over 4B. And then for playing back the video, well, it takes 6 hours to use all the battery when you're playing back a video, and it takes X hours to play back the video. So X out of 6 of the battery will be used. So X over 6 times B. And what is that? Since we're assuming X makes the maximum time you can record a video, then that means whenever you record and play back the video, it should use all the battery. Otherwise, you could have made the video longer. So that's equal to B. So to solve this equation, we can first get rid of B by dividing it from both sides. And then we're left with X over 4 plus X over 6 equals 1. To get rid of the fractions, we can multiply by the least common multiple of 4 and 6, which is 12. So multiplying by 12 on both sides, we get X over 4 times 12. So that's X over 4 times 12 is 4 times 3. So these two 4s cancel. One is in the numerator, one is in the denominator. And then plus X over 6 times, well, this time we can write 12 as 6 times 2. And that's equal to, don't forget to multiply the other side by 12, that's equal to 12. So we're left with 3x plus 2x equals 12, or 5x equals 12. So then we can then calculate x equals 12 over 5, or 2.4. Now, what are we supposed to calculate in this problem? What's the maximum time in hours that you can record and play back a video? So the recording takes 2.4 hours. The playback also takes 2.4 hours. So you should double 2.4 to get the answer of 4.8. Problem number 2. The following graph shows the MPG, miles per gallon, for 5 different cars A, B, C, D, and E. The current gasoline price is $3.6 per gallon. If these 5 cars each drive 100 miles, what is the total cost in dollars for the gasoline? So we see a relationship between the number of gallons and the price. And we see a relationship between the miles driven and the number of gallons used in the graph. So let's figure out the number of gallons used for each car. For A, it's 20 miles per gallon, so every 20 miles it uses 1 gallon, and it drives 100 miles. So the number of gallons used is 100 over 20, which is 5. Now, for B, the number of gallons used, it's 30 miles per gallon, so 100 over 30 this time, equals, let's just write it as a fraction, 10 over 3, it'll be easier. C is 25 miles per gallon, so 100 over 25, and it uses 4 gallons. D is 100 over 40, which is 10 over 4, which is 5 over 2, so it uses 5 over 2 gallons. And E, it's 25 miles per gallon again, so 100 over 25 equals 4, just like C. So let's just record each of those. Let's see how much would the owners of each car have to pay. Let's make it a bit more organized. A, 5, B, 10 over 3, C, 4, D, 5 over 2, and E, 4. Now, let's calculate the price. To get the price, we just have to find 5 times 3.6 plus 10 over 3 times 3.6 plus 4 times 3.6 plus, this is exhausting, 5 over 2 times 3.6 plus 4 times 3.6. That is exhausting. So how can we make that simpler? Well, let's use the distributive property and factor out a 3.6. Now, this is 5 plus 10 over 3 plus 4 plus 5 over 2 plus 4. Let's clear up some space. And now, let's do the calculation. 3.6 times 5 plus 4 plus 4 plus 10 over 3 plus 5 over 2. So 5 plus 4 plus 4 is 5 plus 4, 9 plus 4, 13. And then 10 over 3 plus 5 over 2, let's add the fractions up by using the common denominator. 10 over 3 is 20 over 6. 5 over 2 is 15 over 6. So that's equal to 35 over 6. So we get this sum. Let's write 13 as 78 over 6. Then let's clear up some more space. 3.6 times 13, which is 78 over 6 now, plus 35 over 6 equals, what's 78 plus 35? We'll add the 30, 108, add the 5, 113, and then over 6. And then you have to multiply by 3.6, don't forget. Well, now, this is a bit hard to multiply unless you convert 3.6 into a fraction, 18 over 5. And then we can calculate this 113 over 6 times 18 over 5. This 18 and this 6, well, we can divide this by 6 to get 1. We can divide 18 by 6 to get 3. So we're left with 113 times 3 is 339. And then divided by 5. And then you can find that comes out to 67.8. You can do the calculation. So what have we learned here? Well, one thing, it's very good to convert stuff into fractions. 2, well, the distributive property can really cancel things out sometimes. Problem number 3. Chris received a mark of 50%, oh no, on a recent test. Chris answered 13 of the first 20 questions correctly. Chris also answered 25% of the remaining questions on the test correctly. If each question on the test was worth 1 mark, how many questions total were on the test? And this is from Canadian Math Competition. Well, let's see. 13 questions, total 20. Now, how many questions were on the other part of the test? Well, we can write this as x. And since he only answered 25% of the remaining questions on the test correctly, x over 4. That's x times 25%. So we know that he answered half of the questions right. So this is the number of questions he answered, and this is the total number of questions. So we know that 13 plus x over 4 is half of 20 plus x. Now, these fractions are kind of annoying. Let's get rid of them. Let's multiply by 4. So it will cancel out the fractions. 52 plus x equals 2 times 20 plus x. Then let's expand to get 52 plus x equals 40 plus 2x. So then move this x to the other side, and then move this 40 to the other side. We're left with 12 equals x. So x is equal to 12, but that's not our answer. It says how many questions in total were on the test. So the total is 20 plus x. So 20 plus 12 equals 32. Problem 4. Terrence uses 8 1x1 tiles, 3 black and 5 white, to tile a 2x4 region. How many ways can he tile the region without any 2x2 single color square? A valid example is shown below. Well, it's kind of hard how to start though. How am I supposed to start? Well, if nothing occurs to you, do something that you wouldn't say is that good. And what is that? Let's draw this. You'll see why I'm drawing with these dashes. Oops, I made one too big. Now, how can we get a 2 times 2 single color square? Yes, we're trying to get a 2 times 2 single color square. Yeah, because that's what we have to do sometimes to solve the problem. We have to do it, and then we have to subtract it from the total number of possibilities. What is that? Complementary counting. So these are the 3 possible squares. Now, we can be like a bad boy and say, yes, we want to tile it with a single color square. So how many ways are there to tile the blue one with a single color square? Well, it can't be 3 black tiles. There are only 3. How can you make a 4th one? So it has to be the four of the 5 white tiles. So let's draw that. And I don't really have such a great white, so I'm going to use gray. That was a bit messy. So that's how we tile it. But now, how many ways are there to tile? Well, the thing is, you're just forced to tile the blue square with the white. So the other squares, you can do whatever. Yeah. So what you're left with is 1 white, because you already used 4, 1 white, and then 3 blacks. So really, if we just put the white somewhere, the 3 other blacks have to go in the other 3 positions. So let's put it somewhere. It can be here, it can be here, it can be here, or it can be here. 4 possibilities. Now that's for the blue case. I'm gonna erase all those. But what about the red case or the green case? So let's write it down. Blue, 4. Now let's count the green. So how many are there? Again, you want to tile the green with all white. So let's do that. Now, the other 4 spaces, there's again 1 white because you used 4 of them, and 3 black. So there's also 4 ways. You can put the white anywhere, and then the 3 blacks have to be on the other 3 positions, so 4. Now, how about the red one? Well, let's do it again, all white, because we're doing complementary counting. We want it to be single color. So then we're left with, again, white and 3 black. So there are 4 ways again. Yep, so red, 4. Now, we're done with all the complementary counting, but let's think about it. Can there be overlaps? Yeah, whenever you're doing counting separate cases, you have to remember there can't be any overlaps, or you'll have to subtract something. So can there be overlaps? Like suppose if you had the blue square all the same color, and then you had the green square all the same color. Can you do that? Well, no, you've used too many whites. There has to be only 5 whites, and you use 6 of them. A similar thing happens with blue plus red or green plus red, so no overlaps. So we're left with, oopsies, the total number of ways to put 3 blacks and 5 white on a 2 times 4 region. Well, there's 8 squares. 8 choose 3 or 5. It doesn't matter. 3 or 5. Yeah, that's the interesting thing. 8 choose 3 equals 8 choose 5. And by the way, choose just means how many ways there are of choosing 3 spots from 8. That's 8 choose 3, or 5 spots from 8. Why are they the same? Well, if you choose 3 spots from 8, the other 5 spots are empty. That's basically the same thing as if you choose 5 empty spots out of 8. So, what is choose exactly? Well, 8 choose 3, this particular example is 8 factorial over 3 factorial times 8 minus 3 factorial, or 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1, because 8 minus 3 is 5. We can cancel these, and these 3 ones are just useless. If you divide by 1, nothing happens. If you multiply by 1, nothing happens. And this 3 times 2 can cancel with this 6. So you're left with 8 times 7, which is equal to 56. So now, complementary counting, you have to subtract these possibilities from the total number of 56. So 56 minus 4 minus 4 minus 4, that is equal to, let's clear some space, drum roll, 44. That's our answer. By the way, if you just saw me have the app Brawl Stars on there, well, I'm gonna tell you, I don't play it anymore. I don't play any video games like that anymore. Yeah, I would really recommend you to not do that, because that can really help you do other things and stop like getting addicted to video games. Now, problem 5. As shown in the figure, the shaded part is a square with side length 6 surrounded by 4 rectangles. If the sum of the circumferences of the 4 rectangles is 92, what is the sum of the areas of the 4 rectangles? Let's mark this picture up. Yeah, so now, we can mark a bit more actually. So now what? Oh no, there aren't enough variables to do the job. Well, whenever this happens, remember, Just set variables. Random variables, doesn't matter, just set any variables you can make. Okay, this is W, then this is X, Y, and Z. Yes, 4 variables. That's how many you need to solve this problem. But the algebra won't be as hard as a 4 variable 4 equation linear thing. It won't be that hard. So what you're given is the sum of the circumferences. That should probably be the perimeters of the 4 rectangles is 92. What is the sum of the areas of the 4 rectangles? Yeah, not circumference, it's perimeter. 92 is equal to the perimeters of each of those 4 rectangles. What are they? Well, first one is W plus 6 plus W plus 6. Second one is X plus 6 plus X plus 6. Third one is Y plus 6 plus Y plus 6. And then the fourth one was Z plus 6 plus Z plus 6. This is a mess. Well, we can kind of simplify this, can't we? Let's add up all those 6's. There are 8 6's there, so 48. Let's change this into 48. And then plus, well, there are 2 W's here and here, and then 2 X's, 2, that's a Y, that's Y. 2 Y's and 2 Z's. So 2W plus 2X plus 2Y plus 2Z equals 92. So then 2W plus 2X plus 2Y plus 2Z is equal to 92 minus 48. That's 44. And then W plus X plus Y plus Z equals 22. What's it asking for? The sum of the areas of the 4 rectangles. So what is that? Well, let's look at the diagram again. 6W plus 6X plus 6Y plus 6Z, right? Well, do you realize something? Yes. It's rare we get this lucky, but in a competition problem with an answer, you have to get this lucky. Well, yeah, so we're basically done here. 22 times 6 is 22, 6 is 12, 132. And we're done. Problem 6. In how many ways can one write 8 as a sum of 3 or more positive integers in which the order does not matter? For example, 5 can be written in the following 4 ways. 3 plus 1 plus 1, 2 plus 2 plus 1, 2 plus 1 plus 1 plus 1, and 1 plus 1 plus 1 plus 1 plus 1. Okay, so what is this problem asking for? The ability to count efficiently. So how do you do that? We have to count in a very organized way. So it says the sum of 3 or more positive integers right here. So let's start with 3. So 8 can be written as, and in these organized ways, I'm going to write the smaller number first. It's easier that way. 1 plus 1 plus 6. 1 plus 2 plus 5. And then every time I do this, I make the second to last So this is the last number. This is the second to last number. I make the second to last number bigger every time and then make the last number smaller until this. Well, what is that? It's just another way to say this. And since order doesn't matter, this is not a new permutation. So what happens is whenever we have 1, 3, 4 becoming 1, 4, 3, like when the second to last digit is greater than the last digit, then we can't do that. Then what do? We increase the first digit instead. And then what does happen to the second digit? It becomes the same as the first digit, 2, 2. So that's how you make the smallest number. 2, 2, and then 4. Smallest meaning like if you wrote this in base 10, it would be the smallest, 2, 2, 4. Yeah, you don't want like 2, 3, 3. That would be bigger than 2, 2, 4. Now, let's do the same thing that we did. Increase the tens digit until we can't anymore. Then we can't. 2, 4, 2 doesn't work. Okay, so let's try 3. This should be 3, and then this should be at least 3. But no, this is greater than 8. So this is not a valid partition. And this is called a partition, by the way. Except a partition, it doesn't matter if it's a sum of 3 or more. It just has to be the sum of 1 or more. Like 8 or 3 plus 5, they're also partitions. Now, so we can go on to the 4-digit, since the 3-digit ones are all used. 1 plus 1 plus 1. Now, what must be the other number? 5. Same thing, except now we have 4 numbers to add. 1, 1, 2, 4. 1, 1, 3, 3. Now, we can't make the tens digit anymore. The tens digit, as I call it. So I'll make 1, 2, 2. Then this must be 3 for the sum to add up to 8. Then, well, if we increase the hundreds digit, as I call this one, 1, 3, 3, 3. That's the least you can make as an increasing sequence. But that will add up to 10, so you can't do that. So how about 2? Well, yes, you could have 2 plus 2 plus 2 plus 2. And that's the only way. Because if you made the 2 a 3, then 3 plus 3 plus 3 plus 3 is way over 8. So now 5-digit. This should be a 4 to add up to 8. 1, 1, 1, 2, 3. Just doing the regular adding up 1 to a tens digit. Now, you have to add 1 to a hundreds digit now for this to work. So this adds up to 8. So it's correct. So you don't have to worry about that. If you make a 1 plus 2 plus something, then it will add up to more than 8. This is 9, so it won't work. So now we have to use a 6-digit. 1 plus 1 plus 1 plus 1 plus 1 plus 3. Then 1 plus 1 plus 1 plus 1 plus 2 plus 2. Just doing the regular thing. Now, you can't do anything else, can you? 1 plus 1 plus 1 plus 2 plus 2 plus 2 is over. And then if you make changes to the thousands digit or the 10,000s digit, it's going to be even worse. This is the thousands digit and this is the 10,000s digit, by the way. I might have not been that clear. in the explanation of what is a digit. But now let's do 7 digits. 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2. That's it. And then the 8 digit is just 8 ones. So how many do we have here? Okay, there's 5 here, there's 10 here, there's 13 total, and then there's 4 here. So then there's 17. And we're done. So if you were a bit confused on how I did all this, most of the stuff is basically how to count this an organized way. So you don't have to worry about why this is right if you have the intuition for it. So now we're on number 7. Assume that we have 2 walls, AB and CD, of heights 3 and 5 respectively. Let's assume that there are 2 ladders, AD and BC, between the walls. What is the height, not the height, of the intersection of the ladders, the length of PQ? So do you see anything that can be classified as a pair of similar triangles? How about this? And how about this? Yeah, these 2 similar triangles are gonna help us a lot here. So let's label these. And then let AQ be X and QC be Y. Yeah, this kind of thing, you'll just have to set variables really somewhat carelessly. No matter how you set the variables, you have to get a correct answer in the end. So you can set them pretty carelessly. Sometimes it won't work, but then most of the time it will. So let's do it. And then let PQ be Z too. So we know that BA over AC, or AC over BA, X plus Y over 3, is equal to QC over PQ, Y over Z. Why? Just simply the similar triangles. Again, let's try to find another one. How about XY over 5, AC over D, X plus Y over 5 is equal to X over Z. Why? Well, similar triangles again. Now what do we do? You see an XY here, we see an X plus Y here. How about these? Let's add them. How about X plus Y? That's a great way to make X plus Y. Let's add them then. X plus Y over 3 plus X plus Y over 5, adding these 2 equations, equals X over Z plus Y over Z. Yep, you see this magic? This is just equal to X plus Y over Z. Now we can just cancel all those X plus Y's. This is 1, and this is also 1. So you get 1/3 plus 1/5 equals 1 over Z. So then 1 over Z is equal to, what's 1/3 plus 1/5? Let's change this 1/3 into 5/15, and then let's change this 1/5 into 3/15. That's 8/15. So that's 1 over Z. So we get Z equals 15/8. Yep, and we're done.